In section 69, we will look at the logarithmic function. The use of the calculator is not allowed on this section. Here we have an equation that's written in exponential form, where a is our base, which has to be greater than 0, b is the exponent, and c would be a number that's greater than 0. And that would have to be a true statement. So an example of how that could be written is 5 to the second is equal to 25. Over here, we have the log base a of c is equal to b, where a again is the base, b is again the exponent, and c is a number. And we need to know that these two representations are equivalent to each other. They mean the same thing. The definition of a logarithm is the exponent placed on a base to reach a desired number. So it's the exponent placed on this base to reach this desired number. Now, one of the main goals of today's lesson is going to be, if you're given the representation in exponential form, that we switch it to log, and then if you're given log, we switch it to exponential. So we're going to talk about that a lot today. Some things that I want you to notice right now is our base here is still our base over here. These would go in the exact same position. Another thing to recognize here is that if these two, a and b, are together in this form, they're no longer together in this form. So consider that. Same thing here. If they're together here, this a and c are together here, they end up on opposite sides when we switch the form. Another thing that you can think about here is that we kind of think about this as a wheel. We start with a, that then goes to c, and then it's equal to b. And that's where we're going to get log, the base would be a, of c is equal to b. Or if we're in this form and we're going to exponential form, again, we start with the base a, which you can see here. We raise that to the b power, and that would be equal to c. So we're going to practice that now. On the left here, where we have 5 squared is equal to 25, we want to write that as a log. So to do that, we have the log. The base is still the base. So if our original base was 5, our base is still 5. So it's going to be the log base 5 of 25, and that's going to equal 2. Again, it's this whole idea of a wheel. So it should look like this. You want to make sure that log and 25 are about like the same size. They're all in line with each other. And that 5 is like a subscript. It's written smaller and it's lower. So just make sure that you have that written correctly. You do not want this to look like the log of 525 or anything like that. And then again, that's equal to 2. So go ahead and try that second one there. Now I'd like you to pause the video right now and go ahead and try to complete the next 4 problems. So here are the answers to those 4 problems. For the third one down, we would have the log base 3 of 1/9 is equal to -2. Again, we want to notice that as we change forms, if the 3 and the -2 were together here, they better not be together when I switch it. Over here, we've got the log, base is 3, so base is 3. And then again, it's 3 of 81 is equal to 4. So your equation should look like this. Over here, we've got log, the base is 8 of 2, and that equals 1/3. And then this last one, we've got the log, base is 2, we have of 1 over 32 is equal to -5. Now over here, we're going to do the exact opposite. So for our first example, we're going to keep the base the same. Our base is 2. We raise that to the third, and that's equal to 8. And we know that 2 to the third is in fact equal to 8, so we know that that is a correct representation there. So pause the video and go ahead and try those 5 examples, and we'll check our answers in a minute. And here are those answers. So we have, again, 2 to the third would equal 8. Over here, 2 to the -1st equals 1/2. For this one, 3 to the 4th equals 81. For this one, 5 to the -2nd is equal to 1 over 25. And for this one, 27 to the 1/3 is equal to 3. And again, it's important that we think like, are these in fact true? Well, if we have a negative exponent, it flips our fraction. So this is going to put 2 down to the denominator here. And that's why we're going to have 1 over 2. 3 to the 4th. Well, if 3 squared is 9, then it's kind of like having 9 times 9, which is 81. Here, Again, that negative is going to make that base go to the denominator, and that would make it 1 over 5 squared. And then since 5 squared is 25, we know that that is in fact true. And then 27 to the 1/3, you want to remember that this is going to be rewritten as the cubed root of 27, and the cubed root of 27 is 3. So the next thing we do is going to involve switching this from log to exponential form. So I want you to start out by thinking of log base 1/2 of 1/4 equals x, and you can even write equals x there. That way when we go to rewrite this, we're going to have a base of 1/2, we're going to raise it to the x power and set it equal to 1/4. So we're just switching it from logarithmic to exponential form. Now you just want to think, well, what is x going to have to be in order to make 1/2 to a power become 1/4? Well, let's focus on the denominator here. 2 raised to some power has to give me 4, and that's going to have to be 2, so x is 2. Go ahead and try the next example. Again, we're making that equal to x. So if I make this 1/5 to the x equals 25. Now I want to think, well, first of all, 5 has to come out of the bottom and into the top, from the denominator into the numerator. So that right there tells me that my exponent is negative. Then I think 5 squared would give me 25, and that's why this exponent would have to be a -2. I'd like you to take a minute and finish the rest of the problems on this page. Go ahead and pause the video, and then when you're ready, play through the explanations. So for the third example here, again, if I make that equal to x, I'm going to have 4 to the x equals 1/2. Then I want to think, well, I want that 4 to go to the denominator. So part of this is going to be having a negative exponent. Then we actually are trying to make this decrease in size. And so what that means is that we have to take a root of it. And to take a root of that, we're going to raise that to, it would be the square root of 4 that gives us 2. So we're going to raise 4 to the 1/2 power. So that means that our x here is going to be negative, again, because we want the 4 to move to the bottom, and then 1/2 because we're taking the square root of 4. For our next one, if I set this as 3 to the x equals 27, 3 to the 3rd is 27, that's why this one's 3. For my next one, I'm going to have 8 to the x equals 8, and in this case, x just has to be a 1 for that to happen. For my next one, I write this as 5 to the x equals 25. 5 squared is 25, so the value is going to be 2. And then for my last one here, I'll have 10 to the x is equal to root 10. Well, again, to involve that radical there, we're taking the square root, and that is equivalent to raising something to a power of 1/2. There's a few more problems to do here. In these examples, we've got the log base x of 81 is equal to 4. So our best bet here is going to be to change this into exponential form and then solve. So first of all, the exponential form here is going to say x to the 4th is equal to 81. So now I have to think, well, what does my base have to be so that if I raise it to the 4th, it gives me 81? And that's going to be 3. Try the next one. Again, the setup here is going to be 4 to the -4th is equal to x. Now, you are not using a calculator on this. So first thing you want to think about is what is that negative? How is that negative going to impact the problem? Well, it's going to make it 1 over 4 to the 4th. So we're going to have 1 over some number. Then we want to think 4 to the 4th. Well, first of all, 4 squared would be 16. So we're essentially doing 16 times 16, and that's going to give me 256. So our answer here is 1 over 256. Now for my next one, this is actually called a common log. It doesn't have a base written there, but if there's not a base written there, we assume it's a 10. So we're going to rewrite this then as 10 to the x is equal to 1,000. Now again, you want to think, well, if I had made this 10 to the 1st, it's just 10. 10 to the 2nd is 100. 10 to the 3rd is 1,000, and that's why x is going to be 3. Try the next one on your own. We should have x to the 1st is equal to 10. And then from there, I'm thinking what to the 1st, which means the first power isn't going to change it, is going to give me 10. So our base is just 10 there. Try the next one. And on this one, I'll have 6 to the -2nd is equal to x. Again, that -2 is going to flip my expression, so I'm going to have 1 over 6 squared. 6 squared is 36, therefore my answer is 1 over 36. Try the next one. And this one could be a little bit tricky. We've got 9 to the x is equal to 27. Well, 9 to the first is 9. 9 squared is 81. So that tells me it's somewhere between a 1 and a 2. So one thing that we want to consider here, and we did this recently in a homework set, is let's get the bases to be the same on each side. I could rewrite this as 3 squared, and I have to keep the x there. So I make it 3 to the 2x. And on this side, I'm going to make that 3 to the third. From there, if I have the same base, I can set my exponents equal. So I do 2x equals 3, and I get 3 halves. For this next one, I get 16 to the x is equal to 8. Well, again, with a problem like this, 16 to the first is too big, so it's got to be smaller than 1. I'm going to want to work with a base of 2. So instead, I make 16 2 to the fourth, which still has the x there, and 8 can be written as 2 to the third. So now if I set my exponents equal to one another and solve, I do get 3/4 for that. And then for that last one, I've got 2 to the x is equal to 0.5, but 0.5, if I write that as 1/2, it's going to be a little easier to work with. And here, I want that 2 to move to the bottom. So again, that means I'm going to have a negative exponent. But I want it to stay 2. So I want to raise it to the first so that it stays 2, and that means that x is going to be -1 in this problem. So at this point, you can go ahead and complete the associated problems with this lesson.